notice, and this is the typical copyright. We continue with mathematics syllabus, May-June 2018 for CSEC. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself, the content, remains unchanged. Two main planned changes are: one, to split the exam into two parts, and two, there will no longer be any alternative sections. All sections will be tested. Schedule of videos, as you already know, these first three sections, all 51 of those videos have been published on YouTube in their entirety. Please make good use of them. From sections 4, 5, and 6, some of these have been published in their entirety. 5 there, 5 there, and 7 here. The others have been published partially on YouTube. We are now at section 7, relations, functions, and graphs. This is the 17th of 26 videos. And then after that, of course, we go on to geometry and trigonometry. Hopefully by March 2026, that will be completed. And finally, the last section, vectors and matrices, by April, May 2026. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Reminder from section 1, all 33 of these videos have been published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So please make sure you know these 33 concepts in order to be able to do well in the rest of the syllabus. A reminder here, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Continuing with some more details about section 1, some of these videos are even applicable in primary school for students, teachers who would like to use them in the inverted classroom, and parents who may think that they are not qualified to deal with mathematics with their children. If you look carefully at this blue box, if we expand it, you could see video 6 says add, subtract, multiply, and divide whole numbers. That is work done in grade 4 and even grade 3. But in order to do that, children must know about place values. So place values actually came in an earlier video. And then, of course, you have add, subtract, multiply, and divide decimals. That's video 7. Add and subtract fractions, video 8. And then multiply and divide fractions, video 9. All of these are work done in the primary school. To what extent will determine which grade, maybe grade 4, grade 5, grade 6, so that the students themselves can look at these, either preview or look at it after the class. The teachers can use these in the inverted classroom if they so desire. It makes life easier for the teacher, and of course, it enhances student learning. And the parents themselves could help the children with these basic mathematics principles. That's section 1 in the CSEC mathematics syllabus. As I already said, from section 2, all 12 of those videos are published in their entirety. From section 3, sets, all 6 of these videos are published in their entirety on YouTube. From section 4, measurement, some of these indicated in yellow have been published on YouTube in their entirety. and the others are only partially published. If you need to have full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 5, Statistics. These that you see indicated in yellow here have been published on YouTube in their entirety. The others are only partially published. Same principle applies. If you need full access to those that are only partially published, please see directions in the description below. Section 6, Algebra. These 7 videos from that section have been published on YouTube in their entirety, especially since algebra seems to be a problem area with most learners. And the others are partially published on YouTube. If you do need to have full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 7, which is where we are now, this has 26 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these that you see on the right here. From those, I would recommend these last 2, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is volume 1, Mathematics, a complete course with CSEC questions by Raymond Tulsi. And this is volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, there is a website with AI interactivity that has been made available free of cost as of late 2024, and it deals with past CSEC math questions only from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. The home page is shown on the next slide. This is the home page for that math website. You need to register first and then subsequently, of course, sign in. But as I said, it is free. This is the URL again. That URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Another reminder that this formula sheet is provided for CSEC math examination papers. This one you see here on the left. This formula sheet is included in the syllabus. If you don't have a syllabus, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little closer. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examination. This is the below part of that same formula sheet. Please note that while you do not need to memorize these formulae, you do need to know when and how to use them. So we are back to section 7, relations, functions, and graphs. We have 5 objectives here on this page. Those have all been completed. Next page, we go up to objective 9. Those have all been completed. On the next page, up to objective 13. Those have all been completed. And we are now here. Objectives 14 to 16 have been completed. 14, 15, and 16. Now we are at objective 17. Let's take a brief preview to know how far more we have to go in this section. That's up to objective 20. That's up to objective 22. And we finally reach objective 26, which will bring us to the end of section 7, relations, functions, and graphs. So we have finished objective 16, which was video 16, the last video. Those 6 have been published in their entirety on YouTube, and these others have only been partially published on YouTube. Please make good use of all of these videos, whether they are totally published or partially. When I finish objective 17, which is this one video we are doing now, video 17, this will be published partially. And this is an overview of how the videos from this section have been and will be published. We are here. So you can see that we have 3 more videos to publish in their entirety and some others partially. So as I said, we are here. And it says, state the relationship between a function and its inverse. And the explanatory notes down here says the concept of inverse of a function, you need to know what that is, and the composition of the inverse functions f of x and inverse f of x is commutative and results in x. There's a little condition applied to that, which we will meet soon. So the concept of inverse of function, so we will divide this objective into 4 parts. Part A, we will talk about the concept of inverse in general. Part B, we will talk about the concept of inverse of a function. Part C, we will talk about the composition of the inverse function, that it is commutative and results in x. So actually 3 parts, not 4. To find the inverse of a function, we need to do 4 things, and we will see them as we go along. The inverse function reverses the original function's inputs and outputs, essentially reflecting the graph across the line y is equal to x. Or you could say it, in other words, the range becomes the domain and the domain becomes the range. We will meet inverse f of x again in the next objective, objective 18. But in this video, it is incidental just to show that the composition of f of x and inverse f of x is commutative and results in x. So the concept of inverse in general. Your syllabus states that the inverse of an element under an operation is another element which, when operated on with the first element, results in the identity. For example, the inverse of a real number under addition is the negative of that number. So the inverse of an element under an operation, please note that specification there, is another element which, when operated on with the first element, results in the identity. So let me explain that. An identity element is a value which, when combined with an operation on another number, leaves that other number unchanged. The identity element for addition and subtraction is 0, and the identity element for multiplication and division is 1. Let's look at some examples. For addition and subtraction, the identity element is 0. So if you take 23 and you add 0, you will get 23. This negative 23 here is the inverse, additive inverse. And if you take negative 45 and you add 0, you will get negative 45. So the identity element for addition and subtraction is 0. The additive inverse is plus 45. And the same thing applies for this. 5 plus negative 5 is equal to 0. That is to say, 5 plus 0 is equal to 5. Now that's for addition and subtraction. The same thing holds true for division and multiplication but instead of 0, we are using 1. So we divide or multiply by the reciprocal to get 1. So if you look at 23, the reciprocal of 23 is 1 over 23. If you multiply those two, you will get back 1. That is to say 23 multiplied by 1 is equal to 23. And if you deal with half, the reciprocal of that is 2. You multiply those two, you get 1. So half multiplied by 1 is still a half. And you could deal with 5, but this is division, not multiplication now. So 5 divided by 5 is 1. 5 divided by 1 is equal to 5. So those are the inverse in general for addition, subtraction on one hand, and multiplication, division on the other hand. Now let's talk about the concept of the inverse of a function. An inverse function, inverse f of x, is a function that undoes the original function f of x, meaning if f of x is equal to y, then inverse f of y is equal to x, essentially swapping inputs and outputs. To find an inverse, replace f of x with y, swap x and y, and then solve for y. Now, don't confuse inverse f of x with 1 over f of x. They are two different things. And invertibility, a function must pass the horizontal line test, be 1-to-1, to have an inverse that is also a function. The domain and the range, the domain of f becomes the range of inverse f. So what is the horizontal line test mentioned above?